An interesting little situation that can occur with exponential graphs is you can actually describe transformations in more than one way. So this little note that they have, the first part of this note up here is simply just using index laws and is nothing special. But this second part is certainly interesting. So I want to show you how this works. So I'm trying to use their example here, and when we have this graph y equals 5 to the power of x. Now, I'm going to translate that along the x-axis, so just copy and paste that there, paste it here, and if I transfer this along the x-axis, so they have translated, I think, 3 units in the positive direction of the x-axis. I'm going to actually translate it in the negative direction because I just think it shows the example a little clearer. And if I click my black pen there, that should turn that black. So this graph that I've drawn in here would be, click away there somewhere, this would be y equals 5 to the x plus 3. So we've translated it 3 units in the negative direction of the x-axis. Now you could also describe that translation as a dilation. So think if you chose any x value, you can see how that's been dilated from the x-axis. And it doesn't matter where I choose, that is dilated from the x-axis. So 2 ways to describe it, translation or dilation, not both. How does it work? And what is that dilation? So I'll now use their example where they translated it in the positive direction. So they started with y equals 5 to the x, and because they're translating it 3 units in the positive direction of the x-axis, that becomes 5 to the x minus 3. Now we can write that out as 5 to the x times 5 to the minus 3. 5 to the minus 3 is 1 on 5 cubed, which is 1 on 125. So I'm going to put that whole number in front there. It's not really a whole number, is it? That number in front times 5 to the x. So that, written in that form, because the number is in front, that's your dilation. So the dilation is 1 on 125 from the x-axis, or 3 units in the positive direction of the x-axis. So nice little asides there. Okay, moving up, last couple of examples here. And it says, just try and fit that in the screen there. We have seen translations, reflections, and dilations applied to experimental graphs in the following example. We consider combinations of these transformations. So let's have a go at this, certainly this first one, and I might leave the other 2 to you. See how we go. Y equals 2 to the negative x plus 3. So if I start with my original graph, wrong one, try that one. And if I start with my nice little axes here, perhaps I'll move those over just a fraction, make that a fraction bigger. That looks better. All right. Y equals 2 to the negative x plus 3. So if I drew y equals 2 to the x, and because I'm going to translate it, I'll dot it. There's y equals 2 to the x. What does this negative here do? Well, because the negative is in front of the x, that's a reflection in the x-axis. Reflection in the x-axis. Watch those prepositions. I know you hate me saying that all the time, but bad luck. And we'll mark that in there. I thought I changed colour, but not very well. That's horrible, isn't it? Never mind. And then what have we got to do? Move that up 3 units. So see if I can do a little better when I move this up 3 units. So go up 3 units and something like that. So I'll put in my asymptote there, bend it because I didn't do it very nicely, y equals 3. This point was moved up 4 units, so this would be 0, 4. And if you're not sure, just check it. If x is 0, 2 to the 0 is 1, 1 plus 3 is 4. We do need an extra point on it because I've only got 1 point. I need 2 points to define it. I think I'll just use the point x is 1. So when x is 1, 2 to the negative 1 is 2 to the half. A half plus 3 is 3.5. So I'm going to use that point there, and that point there I said was 1, 3.5. So 7 on 2. Hate my graphs without arrows. Can't help myself. Sorry, OCD. And that's 2 to the negative x plus 3. Looking at these other two graphs that you have here, just looking at what the various bits do. The 3 there, so you draw y equals 4 to the x. That 3 there would be a dilation by a factor of 1/3, not 3. Dilation by a factor of 1/3 from the y-axis. Factor 1/3 from the y-axis. Remember, when the number's just in front of the x, it's from the y-axis, and it's always 1 on that number. So 1 on 3 is 1/3. And a translation of 1 unit in the negative direction of the y-axis. What about this last one here? 10 to the x minus 1. So you've got a translation along the x-axis of 1 unit in the positive direction. The negative, because it's in front of this whole part here, is a reflection in the x-axis, and then a shift of 2 units in the y direction, and that should do it, and that will let you do the rest of the questions.